Hello, Joe Neville here, back with my second video about Aruba AOS-CX and VRFs. In the first video, we looked at the configuration of VRFs on a single device and we delved into the VRF dedicated tables such as the routing table, the ARP cache and the neighbor cache. Links on the screen now. If you haven't watched that video, please do. And configuration on a single device is good for going into the details, but it's not realistic, is it? It's not networking. For that, we need multiple devices. And in this video, we're going to look at VRFs across the network. VRFs are like building blocks for VPNs, but they're only locally significant. So the configuration on one device is not shared with its neighboring device. So the local VRF configuration on one device is not advertised to its neighbor. On screen here, you can see this device on the left is configured with VRF red and VRF blue, but the neighbor is not configured with any VRFs. There's nothing like a routing protocol that can share state between these two devices about VRFs. And that's a really important point when you need separation of traffic across multiple devices. This raises two questions. Firstly, how do we maintain separation of packets across a link? So if our configuration for our VRFs is only locally significant, how do we add some kind of state or tag to our packets to say they originated from VRF red rather than VRF blue? How do we keep the traffic separate? And secondly, if the configuration is locally significant, as I keep saying, how do we configure the network as a whole, like holistically, rather than just individual devices, so that we can maintain this separation as we move from device to device? Here's the network that we configured in the first video. Let me grab my laser pointer. So we had our single device and we had our 4 ports, which are all physical ports that were tied to our VRFs. So 1/1/5 was in red, 1/1/6 was in VRF blue. So this is the simplest configuration. We had physical ports tied to VRFs. Now let's expand out, and I should also say that since I recorded the first video, I've had a delivery of 6300s. So in the first video, I was using my 8320s, but in this, I'm going to use my Aruba 6300s, mainly because they're edge-focused devices and they're a lot quieter to work next to rather than a data center-focused device like an 8320. Anyway, so what I've done here is I've expanded out our single device into 2 devices, and as you can see, I've got my physical ports connected to my servers and my clients over here, as we had in the first video. And then I've got this interconnect between the two. So if we only have a single link between these 2 devices, if you recall the configuration, we can't add a single physical port to 2 VRFs. So we can't do our separation like we were doing previously on the single device with 1 port per VRF. So you might say, okay, so let's add 2 links in between our devices. But of course, then that doesn't scale. It's not a viable solution to have a single physical port on a device dedicated to VRF in most cases. So what do? The solution is that we need to use some form of encapsulation to separate the traffic in transit into their VRFs as they move across this link. And the encapsulation can be of various types. As long as the feature can be VRF aware, then we can use it. So a very simple one, which I'm going to configure here, is VLAN. So 802.1q tags can be tied to VRFs so that we have the VLAN tags creating a relationship between a VLAN number and a VRF. You can also use VXLAN encapsulation, or we can use GRE tunnels that can be tied to VRF, so it will be the GRE header that is keeping that separation, or you can use MPLS. So MPLS is an important part of this. I should caveat that with saying that that's unsupported on AOS-CX at this time, so I won't be delving any further into this, but I think it's sufficient to say at this stage that VRFs and MPLS, especially layer 3 VPNs, go hand in hand as complementary technologies. But for this video, we are going to look at VLAN tagging. So what I'm going to do here with my physical link, I'm going to turn it into a trunk that can run multiple VLANs between our 2 6300s, and I'm going to tie my layer 3 VLAN interface to a VRF. So VLAN 5 is going to be placed, so it will be VRF attached in AOS-CX speak. So we'll have VLAN 5 attached to VRF red, and we'll have VLAN 6 attached to VRF blue. And it's important to remember, as I keep saying, that the configuration of the VRFs is only locally significant. So this VLAN to VRF mapping that we configure on one device, that is not advertised in any way to its neighboring device. So misconfiguration is very possible. So what we could have, for example, what I've put here, VLAN 5 in VRF red here, but VLAN 5 could be in VRF blue on my 63-2, which would mean that the traffic would leave this device in red, hit this device, which would put it into its blue VRF, so its blue tables, and we'd actually be able to ping this device over here if we had that set up, like other misconfiguration. This is an issue when you're configuring these VLANs to VRF mapping, or if you're using GRE tunnels, etc. And that's why with this type of configuration, going in and configuring the individual devices one by one via the CLI with possible typos and having to align the configurations yourself is not a good approach. Step forward, things like single source of truth, automation, or just tried and tested network management platforms to create network-wide configuration management for your devices, which will effectively take the configuration of the VRF to VLAN mapping out of the hands of the individual operator on the single device through the network and place those decisions at a higher level, so a higher management automation platform. But for the purposes of this video, we're going to be looking in detail at the configuration, and we're going to be doing it old school via the CLI per device and looking at the tables. Now, a word on the design, because I've not just incorporated two devices here, I've actually ensured that the 6300s are the gateway between the access subnet here. So you'll see that red server sits on 192.168.105.10 is its IP address. So it's a /24, third octet is what changes here. So it's 105. Then the 6300 here is the gateway for these subnets, and the interconnects are on different subnets. So each device is configured with 4 subnets for V4 and 4 subnets for V6. So 1, 2, 3, and 4. And then that introduces something that I haven't mentioned so far. Of course, routing. So this device is not going to know about these remote subnets over here. So that means that we need to introduce, to get this end-to-end flow working, some VRF-specific routing. And I'm going to go with the most simple approach, because you can have on the device, you can have BGP using VRFs, or you can use OSPF in the VRFs. I'm just going to go with the VRF dedicated static routes to ensure that -1 knows about these subnets over here, and -2 knows about these access subnets over here. Okay, so there's quite a lot there on the screen. It's quite busy, I understand that, but hopefully it will all make sense as we go through the configuration. So let's dive into the demo. Here's my demo then, a lot on the screen. I will keep the diagram up so you can follow along. I'm also on red server and blue server down here if we want to ping. I'm going to start with the 6300-1, so we're over this side. Here's the CLI of my first 6300. I'll show you the config, or the relevant config. So we've got the management, we've already done that, and we've got 1/1/5 and 1/1/6, which are already in the VRFs, because I thought, well, there's no point just configuring the same thing. You saw that in the last video. So we should be able to ping from -1 to red and -1 to blue. So let's do that first. I'll do V6 ping. If you're not into V6, don't worry. Don't be shy about these things. Okay, so 10. Is that going to work? Nope, because I need to use the VRF. Okay, so pinging in the VRF, good. So in the red VRF, we can ping red server, and which to ping blue, it's just 6 there to prove that that doesn't work. Okay, there we are. And if we look at the show IP route, VRF red, There you can see we have 105 connected. There's blue. And of course, we can do the same with V6. Oh, let's go red here. Okay, good. So that's what we've got set up at the moment. So just the local access subnet. And what we need to configure is this interconnect between the two. So that's what I'm going to do now. As I mentioned, those aren't going to be physical links. They're going to be VLANs that we attach to our VRFs and then configure. So the first step is to configure the interface VLANs and then attach the VRF. Remember, or maybe you didn't know this, that when you configure a VRF on a layer 3 interface or a physical port, it strips off the IP addresses. It's always best to create the interface, attach it to the VRF, then add the IP addresses. So let's do that. Interface VLAN 5, VRF attach is red, then the IP address is going to be 5.1 go /24 v6 db8 5/64. Okay, and now for VLAN 6, VRF attach blue. And the IP address is 168.6.1/24 6 address 6/64. Let's have a look at that. I'll come out of here, show run, and there they are at the bottom. So we've got our layer 3 VLAN interfaces. The VLAN 5 is attached to red and VLAN 6 is attached to blue. Let me see if I've already configured that interconnect, the physical side. Configure that. Yeah, okay. So I've already done that part, which is to create a trunk. That's the physical port there, 1/1/1, and I'm allowing 5 and 6 to flow across that. Let's have a look at the interfaces then. So we can do a show IP int brief in a VRF, so red, and we can see 1/1/5 there and VLAN 5, both up. Now if we go blue, okay, so 6 and VLAN 6 up. Looks good. I'll jump over to -2 then. I've not completely finished -1, but let's carry on in the same theme. Here I am on -2. Let's have a look at the config. Okay, so no VLAN configuration yet. I have configured the physical interfaces, so the connection to red client and blue client are already configured. And the physical port is already a trunk allowing 5 and 6. I've already put that on there because that's basic configuration you've already seen in this video series. Now let's go and do the same thing essentially, which is the VLAN 5, VRF attach, red, IP address, .2 for this end. /64, and then interface VLAN 6, VRF attach blue, /64, show IP int brief, VRF red, VRF blue. Okay, all up. Let's have a look at the routing table. VRF red. So we've got the interconnect there, and we've got the access connected to the client there on -2. Okay, so I should be able to ping across the interconnect. I'll go V6, so DB8 5, it'll be 1, VRF red. Okay, that's good. So I'm pinging from -2 to -1 there. Now let's try blue. Okay, of course that doesn't work. And so, but if we change this, okay, so that works. Now we won't have end-to-end from server to client yet in red or blue because of those statics. So that's the part that we need to do. Because I'm on 2, I might as well carry on. I'll do a save. We'll carry on with the static starting with 2, and then I jump back to 1 and finish it off. Okay, I'll go into conf t then, and we will configure the, first of all, I'll do red, and the destination will be the destination /24. So it's 192.168.105 for v4, and this 2001 DB8 105/64 for v6. Of course, we've got to configure separate routes for v4 and v6. Okay, so IP, what is it, route, and then we need the v4 destination. So that's 105.0/24. Then we need the next hop. So from -2's point of view, that is -1's interface here, which I know is 192.168.5.1. Now let's do a question mark, and there you can see the VRF that we can add in. Okay, so if we added this in now, if we hit return, that would be in global, so that wouldn't help us. We need to put that in VRF red. Done. And if the quickest way to do this is just up arrow, and I'll go blue for, change that to 6, and change that to 6. Good. Now let's go for V6. It's 2001 DB8 105 we're going for /64, and the destination next hop is 85:1. There's our VRF. Okay, red, into that, up arrow, blue, 6 and 6. Good. Right, let's come out of there, save that, go to the top. I'll show you the configuration. So here it is down at the bottom. So we've got our 2 VRFs, and V4 and V6. If you want to look at the routing table, of course, we can do that. And you'll see the static for red in there. So that's what I've just configured. And there's blue down the bottom. There's my static. Okay, so that should be good for -2. Now I need to do the same for -1. Okay, let's get off of here. If you're wondering why I haven't got to put in a password, it's because I've configured public key authentication because I'm lazy, so I don't have to enter a password. My authentication is based off of my Mac here is sending the public key to the device. I should show you that in another video, but for now, let's configure -1. So it's the same again, but in reverse. Now we need to go to 192.168.205.0/24. Come on, get this right. And the next hop is 5.2 VRF red. I think that looks okay. Into that, right. Up arrow will go blue. So we're just going for 6. So 206. Into that. Now for our all-important V6. Come on. What is it? 205. Yep. /64. And that is DB852. VRF red. Good. Blue. I've got to change this to 6. And 206. Save that. Right WM is right memory. Okay, show you the configuration. There we are. That's my configuration there. Now, fingers crossed, if we jump over to red server, we should be able to ping red client. Ping 192.168.105. So this is the local gateway for red. So that's red pinging 2. That was successful, so that's red pinging -1. Should be able to ping across this link here as well. Troubleshooting tips, always good to ping each one of the hops separately so you know where something's failing rather than just always pinging end to end. So let's give that a go. So it'll be 5.2. Can we get across there? Yes, we can. So we can go from the server to -2. Now let's try to get -2's far interface. So going through each one of the steps there. That's good. And do we have end-to-end? So -5, come on. Yes, we do. Excellent. Okay, so red can ping all the way. Of course, I don't know why I sound so surprised. It works first time. I should have more confidence in myself. Let's try and ping blue. No, that doesn't work. Okay, so because we haven't configured that, well, I should say we've configured them in different VRFs. So the local gateway here, .1, is saying I don't have a route to that because in VRF red because it's across blue. So if we go jump over to blue, I'll just ping end to end to save some time. Let's do V6 as well. Is that going to work? And it does work. So we've got end-to-end connectivity for blue, from blue server to blue client. Excellent. So our VPNs are in place. Red server can speak to red client and blue server can speak to blue client, but they can't speak to each other. So we can't cross the streams. Excellent stuff. Now if we jump back just to finish off, you should see in the ARP table, VRF red. Okay, so let me expand that then. So we have entries in the ARP table across, this is the local actually, VLAN 5. So that's the interconnect. Yep, 5.2, so that's across the link here. And we have the local for red, which is 10, so I can see that in my ARP table. Now, final thing that I wanted to talk to you about, which really brings home this kind of issue, is just how much overhead there is if you're looking at different VRFs where you have the multiple VRFs that you're configuring on a device. Because I've only got 2. Some devices, even campus devices, will have tens of VRFs. Core devices can have many, many VRFs. And you have this overhead here of what all of this needs to be configured correctly, not only in the VRFs where you've got the red and the blue, but if you're running dual stack, especially, there's a lot of admin overhead for this configuration. A lot of things can go wrong if you're configuring typos. This is why automation, why network management, configuration management especially, is so important for advanced network configuration. Humans just aren't up to the job, or very few of them, of getting all this thing aligned. If you've got 20 VRFs and you're running dual stack and you've got, I mean, 20 VRFs isn't even much, but there you go. I hope you get the idea of the burden that having VRFs and dual stack on a device can add in just for simple things like static routes. So static routes don't scale very well. And as I mentioned, you can use other routing protocols that are VRF aware. So on CX, you can use OSPF or BGP. That's for another video though, because in this video series, I haven't actually covered any of that. So I don't want to cover, say, OSPF or BGP before I've done it just in global, and then we'll move it into the VRF. So I think that's some future content. To close then, thank you very much for watching. I hope you enjoyed that video. Hope you learned something. Do leave me a comment if you'd like to see some other content or other subjects covered. As I touched on there, I think delving into routing would be a good way forward. That's one of the things that I really enjoy, is making routing videos or discussing and teaching routing. But do leave me a comment if you'd like to see some others. I've already got some comments from people. Also, please do support the channel. If you want to see more content, a like and a subscription really do help us. But that's all for now. It just leaves me to say, my name is Joe Neville. Thank you for watching and goodbye.